Hello everyone, welcome to Homework Helper, the series where I take your homework questions and I show you how to solve them. This one is actually one of my homework problems from when I took Calc 1, which is about derivatives. This problem uses derivatives, and I'm basically going to show you how the stuff from the Secrets of Calculus series is used. So the problem is fairly simple. Take the derivative of this function. I happen to have a professor who would like to jokingly give out horrifically complicated problems, not expecting anyone to actually do them, especially since they were accompanied by 10 to 20 non-joke problems. Well, I solved them, and I'm going to show you how you can do the same. Here's the function we're taking the derivative of. That is an ugly function. Well, time to throw the book at it. Whoa, maybe not that book. Okay, I got some royalty-free music here, and we have a 3-step flowchart to solve every derivative. Thank goodness there's no implicit differentiation going on, but we still got plenty to work with. We'll do steps 1 and 2 of the flowchart at the same time and break the derivative down into derivatives that we can big brain, and then we'll do step 3 to all the remaining functions to get our answer. So right off the bat, we can see that we've got a situation where a product rule would be needed. And we're going to keep the d over dt signs and all the in-between steps, mainly in an attempt to keep our sanity. Okay, we now have 2 instances of the chain rule to work with. The derivative of e to the stuff is e to the stuff times the derivative of that stuff. Yep, nailed it. And the derivative of stuff to the 4th is 4 times stuff cubed times d over dt of the stuff. So let's do that. This is looking even worse, and we've hardly started. Why did I do this again? Oh, never mind. Doesn't matter. Because now we have a quotient rule to deal with in the first derivative, and a couple chain rules to deal with in the second derivative. Okay, how about this? Since we now have 2 different terms separated by this plus sign, and things are only going to get more horrible, let's split this function into frowny face of t equaling this first term, and unsure face of t equaling the second term. At the very end, we'll see that smiley face prime of t equals frowny face of t plus unsure face of t. So let's work with frowny face of t first. So now we use quotient rule. Oh boy. We're almost there. We just have to split the first derivative by the addition. Okay, so the first derivative is a product rule to work with, and the second and third derivatives use the chain rule. Let's go one at a time, starting with this first derivative. It's product rule time! We know how to take the derivative of cosine of t, so we can stop here for now. The derivative of arcsine cubed uses a chain rule. And we still have a chain rule involving arcsine. Now, this is one of the weirder derivatives. The derivative of arcsine of stuff is 1 over square root of 1 minus stuff squared, times the derivative of that stuff. And then we split that derivative through the subtraction sign. We know how to take the derivative of t squared and 1, so we can stop there. Phew. That's 1/3 of the derivatives done. On to the second derivative. First we got a constant to factor out. And we got another chain rule to do here with the sine squared. Yep, still got a chain rule. Now the derivative of e to the 2t can be written as the derivative of e to the t, all that squared, which gets us another chain rule situation. And we know how to take the derivative of e to the t, so we can stop there and wait for step 3. Okay, that's 2/3 of the derivatives done. That wasn't so bad. Now we take care of the third derivative, and we'll have frowny face of t ready to go. And that's another chain rule situation. And then we split the derivative to the addition sign. And there we go. We know how to take the derivatives of t squared and e to the t, so we're all good. Frowny face of t is locked and loaded. On to unsure face of t. Here's what we got. So right away, we can split the derivative along the addition. This first derivative is a chain rule situation. So the derivative of 3 to the stuff is natural log of 3 times 3 to the stuff times the derivative of that stuff. And would you look at that, we got another chain rule to work with. And hey yo, another chain rule. This time it's the derivative of arctangent of stuff, which is another one of those weird ones. This is going to be 1 over 1 plus stuff squared times the derivative of that stuff. And we know how to take the derivative of t squared, so we can stop there. On to the second derivative, which appears to be another chain rule situation. Man, my professor loved chain rule. Here the derivative of tangent of stuff is secant squared of that stuff times the derivative of that stuff. Yeah, these are very official definitions. And guess what? Another chain rule situation. This time with e to the stuff. And last but not least, to finish off this absolutely horrendous problem, we have a quotient rule to work with. And finally, we split the derivatives through the additions and subtractions. We know how to take the derivative of t squared and 1, so we can stop here. And now, it's time to zoom out and put together smiley face prime of t. And finally, we do step 3 of the flowchart. At this point, everything has been broken down as much as it possibly can, so it's time to just take all these derivatives. The derivative of e to the t is e to the t, the derivative of t squared is 2t, the derivative of 1 is 0, and the derivative of cosine of t is negative sine of t. Let's see what came out. Yikes! That has got to be the most horrifically complicated function I have ever seen. Nonetheless, that's our answer, in all its glory. I checked it with Desmos, which could barely process this function, and it's correct. So we can clean up the answer a little bit. First of all, e to the t times e to the t is e to the 2t. Also, there's a trig trick involving the sine and cosine, where 2 times sine of e to the 2t times cosine of e to the 2t can be simplified to sine of 2 times e to the 2t. Cool, right? Small confession, I suck at these trig tricks. I only figured this out because Wolfram Alpha reminded me that this is a thing. And there we go. It's not much, but it's honest work. That's our answer. I hope you found this helpful. If you have your own homework questions you want answered, post them in the comments and I'll make a video about it. See you next time!